Algebra 1, Lesson 25, Solving Systems of Equations by Graphing. Now it's time to double up. We are going to start looking into what we call systems of linear equations. A system of linear equations are simply two or more linear equations listed together. Like with single linear equations, there are various ways we can solve and analyze the solutions of a system of them. Graphing is one of the first ways we will look at systems of linear equations. We already know that the graph of a linear equation is a line, so when dealing with a system of linear equations, we need to graph two or more lines. The solutions or solution set of a system of linear equations is at the point where the lines intersect. This means that the solution is a coordinate point, or what we can call an ordered pair. Here's an example of a system of linear equations. We can represent them algebraically and on the graph. As stated previously, the solution set is the point of intersection, which is plotted on the graph. To solve a system of linear equations using the graphing method, follow these steps. 1. Put all of the equations in slope-intercept form when necessary. 2. Graph all the equations on the coordinate plane. 3. The point of intersection of the lines is the solution set, which again will be an ordered pair. 4. You can check your answers by plugging in the values from the ordered pair back into the system of linear equations. Let's do an example. Example 1. Rewrite both of the following equations in this system in slope-intercept form. First, we need to recognize that these equations are written in standard form, and we already learned how to rewrite them into slope-intercept form. Let's start with the first equation. 2x minus 5y equals 4. To put the equation in slope-intercept form, we need to isolate the y on the left side, doing a few basic algebra operations. So we subtract both sides by 2x, then we divide both sides by minus 5, hopefully remembering how to operate with fractions. Now we have our first equation in slope-intercept form, y equals 2/5 x minus 4/5. The second equation is more of the same work. I'll just put down the steps right here. So we'll get our second equation in slope-intercept as y equals 3/10 x minus 3/5. Now that we have our system of equations in slope-intercept form, we do some work to find the x and y intercepts. Pause the video and do the work, and the graph will be in the next part. If you need to review, revisit Unit 3. Your graph should look like this below. If it doesn't, then go back and check all your signs and fraction work. As you can see, they intersect at 2, 0. So that means that 2, 0 is the solution for this system of linear equations. In most cases, a system of linear equations will have one solution. In other cases, a system will be said to have no solution, or infinitely many solutions. When a system of equations has no solution, it means that the two equations are parallel to each other, meaning they never meet, also meaning they don't have any solution. So on a test problem, you would write no solution. When a system of equations has infinitely many solutions, it means that the equations are of lines that overlap and have the same slope. So on a test problem, if you see this, you would write infinitely many solutions. Here are systems of equations that have no solution and infinitely many solutions, represented both algebraically and on a graph. This concludes our lesson on systems of linear equations by graphing. In the next few lessons, we'll look at more computational ways to find the solutions of systems of equations. When it's all said and done, It's all up to you to decide which method is best for which type of system you are trying to solve. See you in the next lesson.